So we are discussing about the Fourier series. In series, what is Fourier series? The types of Fourier series. There are trigonometric Fourier series, exponential Fourier series, cosine series, and discrete conditions. So first we discuss about the what is Fourier series. A Fourier series is the mathematical method to represent a periodic function as an infinite sum of simple sine and cosine waves, each having a frequency that is an integer multiple of the function's fundamental frequency. This process decomposes complex periodic signals into their simpler constituent wave components, which is widely used in fields like engineering, physics, and signal processing to analyze and model wave patterns, vibrations, and alternating currents. So the next topic is types of Fourier series. In for types of Fourier series, there are three types: trigonometric Fourier series, exponential Fourier series, and cosine Fourier series. First, we discuss about the trigonometric Fourier series. In trigonometric Fourier series, there are three representation. First, we discuss about the definition of the trigonometric Fourier series, and next representation of the Fourier series, and the next is example of the Fourier series. First, we discuss about the definition of the Fourier trigonometric Fourier series. The trigonometric Fourier series represents a periodic signal as an infinite sum of simple sine and cosine waves. The original signal is decomposed into its constitute frequency components, which are integer multiples of the fundamental frequency. So the next is the trigonometric Fourier series is defined as the method to represent periodical signals using the sine and cosine functions derived from the exponential form. And the next is representation of the this is the waveform of the trigonometric Fourier series. And the next we discuss about the representation of the trigonometric Fourier series. So the trigonometric Fourier series representation of a periodic signal f x of t with the fundamental period t is given by x of t is equal to a naught plus summation k is equal to 1 to infinity a k cos k omega naught t plus b k sin k omega naught t. Here omega naught is equal to 2 pi by t naught. Here, the trigonometric Fourier series representation of a periodic signal x of t with a fundamental period t is given by ak, means a naught is equal to 2 by t naught integral t naught infinity x of t omega k naught t dt. B naught is bk is equal to 2 by t integral t naught x of t sin k omega naught t dt. And the a naught is the DC component of the signal and is given by a naught is equal to 1 by t naught integral t naught x of t dt. This is the representation of the trigonometric Fourier series. And the next we discuss about the example of trigonometric Fourier series. Trigonometric Fourier series explanation. Let us begin by consider a function f of t which is a periodic period t, that is f of t is equal to f of t plus t. In this equation, we using the shifting operation. As Fourier showed, if f of t satisfy a set of rather general conditions, if may be represented by the infinite series of sinusoids. F of t is equal to a naught 2 plus a1 cos omega naught t plus a1 cos omega naught t, so on, and b1 cos sin omega naught t, or more compactly. Here we seeing the example of the Fourier series. Example: determine the Fourier series of the function f of x is equal to 1 minus x square in the interval of minus 1 to 1. Here f of x is given by x square, interval 1 minus x square. So the interval is minus 1 to 1. So the trigonometric Fourier series equation is a naught plus integral an cos n omega naught t plus integral n is equal to 1 to infinity bn sin n omega naught t. First we find out the a naught value. So a naught is equal to 1 by 2l integral minus l to l fx of dx. An is equal to 1 by L integral minus L to L fx of cos omega naught t. Here omega naught t is equal to n pi x by L dx. N is less than 0. So Pn is equal to 1 by 2 integral minus L to L fx of sin n pi x L dx. So n is equal to less than 0. Now by applying formula fx of n in the interval of -1 to n. So we get these answers. So the next we discuss about the exponential Fourier series. In exponential Fourier series, we discuss the definition of the exponential Fourier series, representation of Fourier series, and example of Fourier series. So first we discuss about the what is exponential Fourier series. The exponential Fourier series offers a compact and efficient representation of period signals using complex exponential instead of sine and cosines. This transformation simplifies mathematical analysis, especially in the context of signal processing, communications, and system engineering. By consolidating the Fourier coefficients into a single complex term, it becomes easier to manipulate, differentiate, integrate, and analyze signals in both time and frequency domains. This representation is especially powerful in time and frequency domain. This representation is especially powerful in applications such as modulation, filtering, and spectral analysis, where working with exponential functions along naturally with the behavior of linear time invariant systems. This is the exponential Fourier series definition. And the next, this is the exponential Fourier series representation of the signal. And the next we discuss about the representation of the exponential series. The complex exponential Fourier series representation of a periodic signal x of t with fundamental period t naught is given by x of t plus t is equal to x of t for all the t. So x of t is equal to, so we get the final equation is Cn x of n is equal to summation of k is equal to 0 to n naught minus 1 Cn e power j omega naught n 2 pi by n naught. Here ck is equal to 1 by n naught integral k is equal to 0 to n naught minus 1 x of n e power minus j and omega naught t. And the next we discuss about the example of the exponential Fourier series. Here we consider the original signal to be periodic continuous triangular wave and derive its Fourier series coefficients. The detailed steps are not shown in the below. We start with the function form of the original triangular wave. First we discuss about the x of t is equal to summation n is equal to 0 to infinity Cn e power j n omega naught t dt. Here Cn is equal to 1 by t integral minus infinity to t x of t into e power minus j n omega naught t. So by applying these expressions and we get the answers and we get this final output waveform. And the next we discuss about the cosine Fourier series. So first we discuss about the what is the definition of the cosine Fourier series, representation of the cosine Fourier series, example of the cosine Fourier series. So first we discuss about the representation of what is the cosine Fourier series. In this section, we are going to take a look at Fourier cosine series. We all start off much as we did in the previous section where we looked at the Fourier series. Let's start by assuming that the function fx of x we will be working with the initially is an even function. And the representation of the cosine series is the fx of minus x is equal to fx of x. This is the representation of the cosine series. And this is the example of the cosine series. So finally we discuss about the Dirichlet conditions. So the Dirichlet conditions are a periodic signal x of t has a Fourier series. If it is satisfies the following conditions, x of t is absolutely integral over any period, namely integral min a to a plus t x of t dt is greater than infinity. X of t has only a few number of maxima and minima over any period. X of t has only a finite number of discontinuous discontinuous over any period. So we discuss about the Fourier series. In Fourier series, what is the Fourier series and types of Fourier series? In types of Fourier series, there are three types: trigonometric Fourier series, exponential Fourier series, and cosine Fourier series. So the trigonometric Fourier series, the representation of the trigonometric Fourier series is x naught is equal to x of t is equal to a naught plus summation n is equal to 0 to infinity a n cos n omega naught t plus b n sin n omega naught t. Here a naught is equal to 1 by t 1 by 2 t integral t naught to t naught plus t x of t dt, and a n is equal to 1 by 3 integral minus infinity to minus integral t naught to t naught plus t x of t cos n omega naught t dt, and the bn is equal to 1 by t integral t naught plus t bn sin n omega naught t. This is the formulas of the trigonometric Fourier series. And the next we discuss about the exponential Fourier series. The exponential Fourier series representation is x naught is equal x of t is equal to summation n is equal to 0 to infinity cn e power jn omega naught t. Here cn is equal to 1 by t integral t naught integral minus infinity to infinity x of t e power jn omega naught minus jn omega naught t dt. This is the formula for cn. And the next we discuss about the cosine series, and the next final we discuss about the Dirichlet conditions. This is the total of Fourier series. And thank you.